That's everything. Not here. Okay, perfect. So we have a function. Is it the fourth? Yeah, already. Okay, perfect. So we have a function which is -2 x minus 3 squared plus 8. Okay, so we are asked to graph everything. So the question will tell you graph using or present the whole list. So first thing I need to do is find the shape, because I know this is a parabola or a quadratic function, and it has two possibilities. Either it has a minimum and it opens upward, or it has a maximum and opens downward. This number, which is a, which is -2, is a number less than 0, which means the parabola has a maximum, not a minimum. So when I'm done, my graph better look like this, not like this. If it does look like this, then I have a terrible error somewhere. So without even graphing, I know which of the two shapes applies here. And number 2, I have to determine the vertex. Because the squared is completed in this function, all I have to write is 3, 8. So there's no requirement for any calculations. Let me refresh your memory how this works. So the general form will be a x minus h squared plus k, where the vertex is this. Now, I want to show a different example. If we have, for example, let's say function g of x, and we have 3x plus 4 squared and plus 4, here the vertex will be -4, 4. Whatever I have here, it stays. But remember, we have to have a minus, which I don't have the negative sign. I don't have it here. It's positive. So you have to imagine the negative in parentheses, -4. In this case, since we do have the minus, then it's 3, 8. No calculations are required. In number 3, I want the x-intercept. But I have to think for a moment. We said, because they may exist or may not exist, we identify the shape from the very beginning, and we know there are 3 possibilities for a maximum. This is one possibility. This is the second possibility. And this is the third possibility. The question is, if it's this, x-intercepts don't exist. If it's this is the vertex and the x-intercept, but that's not the case. So these two are not possible. Also, the maximum is a positive number. Here the maximum value is negative. Here the maximum value is 0. Only here the maximum value is positive. So therefore, it's this case, and there I will be able to find 2 x-intercepts, this one here and this one here. That analysis comes only from the vertex and the fact that the shape is it's a maximum. Either the maximum is a negative number, that's not the case. Either the maximum is 0, that's not the case. Or the maximum is a positive number, and that is the case. Is that clear?
So then the original function had been.
So if the vertex were, for example, let's say 3, -4, it would have been this. For this one, it would have been 3, 0. But that's not the case. So we have 3, 8. I know. Why do I need this analysis? Because I don't want to waste my time. If the solutions don't exist, then I'll say none. And I move on to the y-intercept. So then I have -2 x minus 3 squared plus 8 equals 0. That's how we determine the x-intercept. We have to set y equal to 0, correct? Perfect. Okay, so I move a to the other side. This is a quadratic equation, and I'm thinking of applying one specific method, but not before I clean it up. I will have to divide both sides by -2. So then x minus 3 equals 4. And there is only one method I can think of right this moment, which is
Well, you have perfect squares on both sides.
correct.
So you can take the square root.
Exactly.
And even if you didn't, you could still take the square root.
That's true, but not if I have x here.
Okay.
If I have x here, I cannot take the square root. X has to be isolated on one side inside the square, and just a number on the other side. Is that clear? Because if we have x on both sides, we can never take the square root. It doesn't work. Good. So don't forget to put plus or minus, and we move 3 to the other side. And we get x equals 5 and x equals 1. So we determined two x-intercepts, as we expected, distinct x-intercept. This is not distinct. There are two, but only one, right, basically.
Question.
Yes, please.
If you had made the mistake of opening that x minus 3 square out and combine in my term, do you get the same answer?
Oh, absolutely. Let's just do that.
This takes a long,
Yes. Yes, because this is typical for taking square roots. That's why we even study 4 methods. Although I have to say that completing the square, right? Everybody says, you said that to me also, that I'm not positive on completing the square. I'm not. You're right. I'm not. So, but that's why we have taken square roots as a method. Because why would you expand and move the term and say and combine like terms and set equal to 0 and then use factoring or quadratic formula if we have this method? It's quite useful. Okay, so 5, 0, 1, 0. In step number 4, I want to find the y-intercept, so I only have to plug in 0. But now this is slightly more difficult. How much is 0 minus 3?
Minus 3.
Negative 3 squared is 9. 9 times negative 2. Negative 18 plus 8. Negative 10. So 0 comma negative 10 will be the y-intercept. Now we do have, can anyone give us the range, for example? We haven't even graphed it, but now we know everything about the function. From negative infinity to?
8.
Exactly. Perfect. So the max is 8. And 7, axis of symmetry. It's the vertical line going through 3, 8. And that is x equals 3. Now we really dissected this fully. So now when I graph, I start with a vertex 3, 8. I continue with the axis of symmetry, which is not part of the graph. I plot 1 and 5. 3, 4, 5. Make sure that these are symmetric, 2 units apart in this case, both sides. And the y-intercept is 0, negative 10. So here's the graph. Of negative 2, x minus 3 squared plus 8. And as I said, we knew everything about it. Very good question, Bob. Anything else?
In the homework,
Yes.
I have an example of talking about logarithm.
Yes?
They have an example of e raised to the log.
Let's do that.
E of x.
Yes, let's do that right
Why
now.
is that always equal to odd math?
Let me write it. So can you say it again?
E raised to the log of x. I'm sorry,
You mean natural log?
Natural log. Right.
Okay. And the answer is x.
Why is that?
We have not discussed this property. Actually, we haven't discussed any properties per se of natural log. Very good. So let me explain this. It's a very good question. Okay. So let's say we have e to natural log x, and we have no idea what this is. I'm going to call it y. I don't know what it is. Okay? So this is an exponential equation. Just disregard this piece. So it's a base raised to some power equals a number. Agreed? Okay. So now I would like us to change this into a log equation. So, you know, we're going to have a log, something as the base of a number equals another number, right? So now let's look. In this equation, please name the base. Read the base to me. E. E is raised to which power?
X.
No. E is raised to power. Very good, awesome. And what is the number as the result?
Y.
Good. Let's try this again, going backwards to make sure that this is clear. E raised to this power equals y. Do I have that? E raised to this power equals y. Do I have it here? Yes? Good. Now I have to make an adjustment. Every time the base is e, I cannot use the notation log. I have to use a notation for base e, I have to use a notation ln. So instead of log base e, I replace it by ln of y equals ln x. What can y be? And now be careful, because natural log is a one-to-one function. If you say natural log 3, then I have to have 3 here. If you say 5, then I have to have 5 here. If you say 100, I have to have 100 here. But I have x. So what could this be for these two to be the same? What could this number be?
X is 0.
It can be only x. Only natural log x equals natural log x. But what was this? This was what I just denoted by y. So then this is x, therefore this is x.
It's very abstract. I basically have to sit down and think about what.
Yeah, so once you understand the mechanism, then it becomes easy. Let's do one more so you see it better, because maybe ln is confusing. So let's say 5 raised to log 5, it has to be the same. One more time. This number and this number have to be the same. If they're not the same, then the property is not applicable. So if I have 4 raised to log base 3 of x, the property is not applicable. It's just another number, whatever that is, whatever x is. But the property is applicable only if this and the base of the log are the same. And here I chose an example in which the base is 5 and the base is 5. And let's say we don't know what this is. We're going to call it y. So now let's change this exponential equation. You can say, but it's log. Well, it is exponential first. 5 raised to an exponent equals y. The exponent can be anything. So now let's change this into a log of some base applied to some number and equals something. So let's analyze this side here. Don't look at this for a moment. And tell me which one is the base from all these numbers. 5, whatever I covered here, and y. Which one is the base?
5.
That's it. What do I raise 5 to? I raise it to log base 5 of x, not to itself. Okay, log base 5 of x. So 5 raised to log base 5 of x, 5 raised to log base 5 of x equals?
1.
And now let's compare these two. They have to be equal. Log base 5 of 3 cannot equal log base 5 of 15. If they are the same and they have the same base, these numbers must be the same. Otherwise, the logs will not be the same. You can plug in the calculator and put here 5 and put here 10. They're not going to be the same. Only if these two are the same, the two logs are the same. Therefore, I know that is x. So this is the property. A raised to log base a of x equals x. Remember, this and this must be identical for the property to be applicable. Very good question. I just think that this is part of the next course. I don't think that it's part of this one. That's why I didn't mention it. But thank you for asking. So that's how it works. And to be exact, you will not see this till calculus 2, not even in calc 1. Very little. Very, very little when we differentiate this function. But other than that, you're going to see it more in calc 2. Very good question. Okay, so let's go back to the topics. Any topics that you would like? Let me show you them again to you, and you point out, and we'll either make one up or we'll look in the book. So simplifying radicals, complex rational expressions, radical equations, rational equations, quadratic equations, systems, transformations, reading from a graph. Please say stop on anything. Parallel and perpendicular lines.
How about transformation?
Excellent. So let's take a look. Let's say we are asked to present the transformations on a function like this. Okay, so we have to identify the base function. What is the base function in this case? Which function did I use to create this one? Which, say it again. I'm so sorry. I'm sorry, I forgot to turn off my phone. I'm sorry, I'm sorry. I'm sorry. Shut up. Sorry. Sorry. How do I turn this off? I have an appointment tomorrow and they're calling me like frantically. I already answered the text 3 times and they're still calling to confirm the appointment. I'm so sorry. So the base function is x squared because I don't have x, I have x squared. So it's the quadratic function. And number 1, the first transformation in order of operations is negative x squared. So what do we do here? What does this do to this? And remember, when we talk about transformations, we always ask ourselves, is this a change in x or a change in y? No, we're not changing x. It's completely outside. Do you see that there is no difference between these two? And the change is completely outside? A change in x will look like this. This is a change in x. Here I started with x. If you want x minus 0, if you'd like to compare like that. And here I have x minus 2. So obviously there is a change in x. But that's not the case here. X squared is the same with x squared.
So that's like minus x squared plus 0.
Right. So it's outside. So this is a reflection with respect to the x-axis. in the next step and the final step, we have negative x squared plus 3. Compare again and find out if we are changing x or we are changing y. Exactly. So it must be a change in. Exactly. Awesome. So it's up 3. So it's a change in y. That's all we need to do. So first I will graph x squared, which we know now how to graph. This is x squared. Then you told me to reflect. Yes, I'm going to reflect. Here's the reflected portion or graph. And then you said go up 3. Can anyone give us the vertex of this parabola?
0, 3.
Perfect. So this is the final graph. This one, negative x squared plus 3 with a vertex at 0, 3. Axis of symmetry, x equals 0. Very good.
One side question. That function would not have inverse because of the horizontal line test?
Because of the horizontal line test, it's not 1-to-1. But I can make it.
You limit the domain.
The domain. Exactly. We say we restrict the domain or we truncate the domain. Same thing. So if I define it on this from negative infinity to 0, or if I define it on 0 to infinity, I create a 1-to-1 function that by the horizontal line test is 1-to-1. So in certain situations we do that. Okay, very good. Let's go back to should we go back to test 2, or is there anything from here? This is test 1 still. We want to go to test 2?
Can you review square roots involving negative numbers? We have the background.
Excellent. Yes. So let's do that. Let's say I have negative 3 plus the square root of negative 18 divided by 6. Sorry, thank you. Is this a type of example that you wanted to look at, or adding, subtracting, multiplying?
No, this is good.
Okay. So first of all, I see that this is not a real number, and I will take it aside, and I have negative 18. The first thing I do is this. Then I know that 18 is 9 and 2. And now I decomposed it to the bone. This is the I, this is the 3, and no one can simplify that. So just this piece will become 3i the square root of 2. So negative 3 plus 3i the square root of 2 over 6. I must separate the fraction into negative 3 over 6 plus 3i the square root of 2 divided by 6. So I can simplify 1/2 and 1/2. So the final simplified form is negative 1/2 plus I the square root of 2 divided by 2.
Can you also put a factor of 3 out of the denominator and the numerator?
Yes, that's another option. Perfect. So, or negative 3 plus 3i the square root of 2 over 6 as 3 negative 1 plus I the square root of 2 divided by 6. And then you will simplify, but you still have to separate it because it's a complex number. Otherwise, I would not separate it. But I have to separate it because I have to show the a plus bi. Only because it's a complex number. So a, the real part is this, the I is this, and the imaginary part is the square root of 2 over 2. I'm not that particular on this. So if you don't separate it, then you're still getting full credit. But in order to present correctly, to correctly present a complex number, I have to emphasize a plus bi. But it's not such a big deal. Good, very good. Next topic. Anything else from this test? The final exam will be a subset of the problems you saw on test 1 and 2. Anything else from test 1 you would like to review?
Do we have classes with it?
Today is the last day of classes. Next week there are only final exams, and we only meet one more time on Wednesday, a week from today, for the final. I'll be here from 12. So come in as early as you want, and I'll be here the entire day because all my classes have exams, finals.
Can we take a brief look at graphing absolute value functions?
Excellent. With the transformations, without transformations?
With the transformation.
Very good. Let's take a look. So we have f of x. Let's say is the absolute value of x plus 2 minus 3. What is the base function that I use to create this function?
Is it just f of x equals the absolute value of that?
That's it. This is the base function. This is the function we use to create this. Now, the first transformation is x plus 2. We have to analyze and compare, in other words, and find out if it's a transformation in x. Because if it's a transformation in x, the graph goes left and right. If it's a transformation in y, the graph goes up or down. Or a reflection, who knows? So is it a transformation on x or a transformation on y? It is on x. Awesome. So we are changing x inside the absolute value, right, into x plus 2. So if you want to visualize this better, you can visualize this with plus or minus 0. It doesn't matter. The same thing. So we had x plus 0 or minus 0, and all of a sudden we have x plus 2. Obviously, it's a transformation in x. Excellent. And now the question is, if it's a transformation in x, it goes left or right. But which direction does it go? Indeed, it goes to the left. Left 2. Awesome.
Which seems to be
right. Yes, but at negative 2, it will be 0. Not at 2. That's why it goes to the left. Very good. Yes. Good. And the final transformation would be x plus 2 in absolute value minus 3. Now we compare these two, not with the base. Now we compare these two and we say, what transformation is this? Am I changing inside or am I changing outside? Yes, which means down 3. Excellent. So now it's clear that it's a transformation on y, and it shifts this graph down 3. Sorry. Without identifying the function, you will not know what to graph. The base function is what is used to create the function itself. If I don't correctly identify that, so for example, if I say, oh, the function I used is x, then I'm going to graph a straight line. But the absolute value is not a straight line. So it's a mandatory step. Without that base, I don't know how to graph and what type of function is it. So on the previous one, if I didn't correctly identify the base function, and I said, for example, it's x, then I would have not graphed a parabola. Here, if I don't identify correctly the absolute value, then I will not graph the function that I was given. Is that better? Okay, so the absolute value we had it on that test is this. It bisects the first and the second quadrants. This is the absolute value of x. Then you said to shift this 2 units to the left, which is perfect, all parallel to the previous. So this is the absolute value of x plus 2. And then you said shift it down 3. Perfect. So it's right here and parallel. This is the final graph. So this is the absolute value of x plus 2 minus 3. Can anyone give us the range of this function?
Which one? Which one?
The function we graphed. The final function. Of course. The final function, what is its domain?
-3.
Awesome. The range, yes. The range will be -3 to infinity. Very good. What about the domain of an absolute value function?
All real numbers.
Of course. Absolutely, all real numbers. Is this better?
Again, there's no inverse function.
There is no, because it's not 1-to-1. Good. Can we look at the next topic? Okay, more radicals. Anything else from test 1? We can come back to it. We still have an hour. You want to go back to test 2, or do we still have anything here?
Fractional exponents.
Very good. Very good. So something like this. You want a division, a multiplication, a simplification. Which one? A division. Very good. Excellent. So let's take a look. So let's say we have x raised to 1/4, everything raised to 1/2, divided by 2x to 1/3. Is this something good enough? Okay. So first of all, I have to simplify the top and copy the base, multiply the exponents. 1/4 times 1/2 is 1/8. The denominator is 2x to 1/3. There's nothing I can do to 1/2. 1/2. But these have the same base. I will copy the base. What happens to the exponents? What operation do I perform with 1/8 and 1/3?
Subtract.
Of course. Yes, 1/8 minus 1/3. In order to subtract them, I have to find the LCD. What is the LCD of 3 and 8? Say it again. I'm not asking about the greatest common factor. I'm asking for the least common denominator. They have nothing in common. It must be 24. 8 and 3 have nothing in common. This is 2 to the 3rd, and this is 3. So the least common denominator must have all factors and also the power. So it's 24. This one needs to be multiplied by 3, and this one needs to be multiplied by 8. So then 3 minus 8. 1/2 x2 -5/24. We don't like negative exponents in the final answer. What does a rational exponent mean? When I see an exponent or a power that is a fraction, what does that mean? What triggers my mind?
Some type of rounding.
Exactly. Awesome. And this is it, the 24th power of x to the 5th. Now I want to rationalize this. I have to use the same index, otherwise I can't multiply them. So I need a perfect 24th, but I only have 5. So how many more do I need to form a perfect 24th? I only have 5. 19. Exactly. So the numerator stays as this product, the 24th power of x to the 19th, and this is obviously 2x. We made it to be 2x. X to the 24th, this 24th root of x to the 5th times the 24th root of x to the 19th is the 24th root of x to the 24th, which is x. If we know that x can be any real number, then I will have to use the absolute value. If I'm told x can be only positive, then, of course, and not 0, then I will just leave it as is without the absolute value. Yes. So if the problem tells us that from the very beginning, let's say x is positive, then I do not need the absolute value here. But if we're told that x can be any real number, of course not 0, then I have to use the absolute value. The 24th root of x to the 24th is the absolute value of x, if x can be any real number. If I'm told x is positive, don't worry about absolute value. But if I'm told x can be anything, and we had an example like that. It was right here. So the 4th root of x to the 4th is x. The 4th root of x to the 8th is y squared, of y to the 8 is y squared. But I specifically said, assume that x and y can be any real number. There is no need for the absolute value on y squared. That is always positive no matter what. But there is a need of the absolute value on x. The 4th root of x to the 4th is not x, if x can be any real number. It's the absolute value of x.
Because if you don't have that restriction, then you can have imaginary numbers that exclude.
No, very good question, very good question. Hold your thought. No. When we looked at this function, as the square root of x, and we graphed it, first of all, we said that this piece has to be greater or equal to 0. And then when we graphed it, we said, oh, so it's not that the inside has to be positive or 0, but also the answer is positive or 0. Look at the range. It's not just the domain is positive or 0, but also the range is positive or 0. So the 4th root of x to the 4th, if I just write x, if I use x equals -1, -1 to the 4th is 1, and this will be the 4th root of 1, which is 1, but then this side is -1. And I'm telling you that 1 equals -1. This piece is 1, and this piece is -1. So I'm telling you, if I owe you $1 or you owe me $1, is the same thing. It's not, right? +1 and -1 is not the same. So that's why we need to put the absolute value here. And now this is true. The left-hand side is positive, the right-hand side is positive, no matter what. So it comes from here. The answer of an index that is even always has to be positive or 0. It doesn't happen with a cube root. This is a friendly root. Positive, 0, negative. Answer positive, 0, and negative. We don't care. Anything goes. If this is 0, then this is 0. If this is here positive, then the answer is positive. If this in here is negative, then the answer is negative. No worries. Why? Look at the graph of the cube root. This is the graph of the cube root. Nice. It exists for any real number. You name an x, I'll give you a y value. But not here. If you say plug in -4, I say sorry. I can give you a y. It doesn't, the vertical line x equals -4 does not cross the function. I can give you a y value. It's undefined, it's imaginary. But here, if you say plug in -8, fine, I'll give you -2. If you say plug in 27, I'll say fine, I'll give you 3. But here, if you say plug in -4, I'll say sorry. If you say plug in -1, I'll say sorry, it doesn't cross the function. But if you say plug in 4, then yes, I'll say 2. So
the actual value is kind of have a restriction on the range.
Restriction on the range, yes. It's the answer is always positive, yes. You can plug in anything. So the domain is anything, but the range is restricted, 0 to infinity. But if it has transformations, that's why I always ask every now and then, I ask, what's the range of this? Although it's the absolute value, but it has a transformation. It's pulled down 3. So that's why the range starts at -3. So pure function is one thing, but when you start throwing in transformations, anything can happen. Reflections, up, down, asymptotes, left, right, stretches, shrinking, anything can happen. But that's why we always start with the pure function or the base function. We need to know the shape for that. Very good discussion, awesome. Okay, next question. Should we go back to test 2? Let's go back to test 2. We can come back to test 1 anytime. Okay, let me check this. Okay, 42, and we can still take few minutes. Okay, we talked about this already, unless you want more examples. Do we have any difficulties with creating the sum difference product ratio? And finding the common domain and the domain of any of those? Okay. What about showing that they are inverses or not inverses of each other? Are we okay with that? Graphing, both on the same coordinate system. Basically reversing the coordinates. So this one was 2, 0. It turned into 0, 2. This one was 0, -4. It turned into -4, 0. And they are reflected with respect to y equals x. Any questions on this? Okay, we use transformations on other functions, on 2 functions, on the absolute value and x squared. Do you need me to show again how to determine the compound, the amounts? Do we know how to plug them in the graphing calculator? Do you need me to show again? Is it a yes or okay? Okay, perfect. We looked at imaginary numbers. Do we need more with complex numbers? So we looked at the problem like this, actually. We did look at the taking square roots method. Would you like to review the completing the square method? Yes? Yes? Okay, perfect. So let's take a look at a quadratic equation in which we are asked to solve by completing the square. You know, my favorite method. No, it's not, by any means. It is my favorite method, but not for solving quadratic equations. Okay, so let's say x squared plus 4x minus 3 equals 0. Is it in descending order?
Yes.
Good. What is the leading coefficient? We always take numbers with their sign in front. The middle coefficient is, and we divide that by 2. So the first step is descending order and identifying the middle coefficient, 4. In step number 2, I divide 4 by 2, and I get 2. In step 3, I square 2, and I get 4. This is what I need to add to both sides. Remember, we must add to both sides. At the same time, I'm going to move 3 to the other side. So the left-hand side is x squared plus 4x plus 4, and the other side is 7. So one more time, the middle coefficient, we divided by 2. We squared the result, and the result was 4 in this case. Therefore, we added 4 to both sides. What happens next? What do we need to do next?
Well, the left side can be factored into a perfect square binomial.
That's exactly why we did that. That's exactly why. And what is that binomial that changes squared, that changes into x squared plus 4x plus 4?
X plus 2.
Exactly x plus 2. Exactly x. So first of all, it's plus because of the middle coefficient is positive, and it's plus 2 is the number that I squared to get 4. And now, if I don't remember what to do next, I get stuck. So completing the square alone does not solve the equation. Now I have to remember that I need to take the square root. And then I have x plus 2 equals plus or minus the square root of 7. And then I put the 2, insert the 2 between the equal symbol and plus or minus. Nowhere else, please. You do not need to separate them. Why? You cannot simplify them.
Would you do me a favor and do the same problem with the quadratic formula?
Yes, absolutely. So with the quadratic formula for the same problem, it's in descending order. So I have x equals negative b plus or minus b squared minus 4 times negative 3. So I change it into plus. 4 times a times 3 divided by 2 times 1, which is 2. You can put the negatives, but then you have to use a lot of parentheses, so be careful with that. It's not wrong. So x equals negative 4 plus or minus. 4 times 3 is 12. 12 plus 16 is 28 divided by 2. But now the square root of 28 has to be changed into the square root of 4 and the square root of 7. So therefore, x becomes negative 4 plus or minus 2, the square root of 7 divided by 2. You either separate, or as Bob said earlier, factor out a 2 and simplify, whichever you prefer. But when I separate, I get negative 2 plus or minus the square root of 7. So x equals negative 2 plus or minus the square root of 7. And this is, of course, has to be the same answer, no matter what. Any questions on this? So let's look at other problems and see. We just graphed a parabola today. We reviewed this. Which other problem from the test you would like to review? Anything else? Anything else? Yes, Jay, you had a question? Go ahead.
So
Say it again. Oh, okay.
the final exam gonna have the exact same questions on
Not exactly the same. No, of course not. But remember,
it?
you
Not the
have.
exact same
Say it again.
Not the exact same question I gave